Hi, my name is Debbie Baines. I work at the ESASky Science Data Centre in Madrid and I'm the product owner of ESASky. And I'm going to introduce you now to the ESASky tool and to pyESASky, which is the Jupyter widget for ESASky. This presentation is on behalf of the ESASky team, in particular Bruno Merin, Guido De Marchi, Fabrizio Giordano, Elena Racero, Marcos Lopez Caniego, Elena Puga, Henrik Norman, Matthias Wangblad and Thomas Fossi. The goal of ESASky is a scientific tool to facilitate data discovery and archival science, and it is a multi-mission and multi-wavelength portal with access to data from more than 60 space-based and ground-based missions. It's driven by scientific use cases and the needs from the science community, and it is an interface that lies on top of all the ESA astronomy archives and archives from other space agencies and ground-based observatories. It doesn't replace the archives, but instead provides a different type of access to the data via an all-sky exploration interface that is project agnostic. Over the past 6 years of development, ESASky has turned into a platform and a suite of tools for scientists. So we have the platform at sky.esa.int that can be opened from any browser in your PC, your tablet or even your mobile phone. We are currently repatriating Hipparcos data back to ESA, and ESASky is therefore becoming an ESA legacy archive. And then we have programmatic access via a number of different ways. So via a Jupyter widget called pyESASky that has been developed to work in Jupyter Notebooks, where you can perform additional scientific use cases that you can't do in the main interface. We also have an Astro Query module, and we have a table access protocol or TAP to ESASky. And of course, you can use any of these tools to create scripts or Jupyter notebooks that are then reproducible and can be shared with collaborators. So let me go to a demo of ESASky and pyESASky. And here we have ESASky. When you first open ESASky, you see this welcome box. We have two modes, Science and Explorer. I'm going to show you the Science mode today, which provides you with all the scientific functionalities available in the tool. So ESASky is an exploration style interface, as I said, and the entire sky here is available for you to search and explore, so you can zoom in and zoom out and pan around. Over here we have the search box, where you can search for any astronomical target, any solar system object, and you can also search by author or bib code and see the associated sources for a given author or paper. Now I'm going to go to the Horsehead Nebula. So here we're looking at sky, background sky in the optical with DSS, and you can change these background skies if you click on this first button here, and you can select via wavelength many different HIPs. So these are hierarchical progressive surveys that we're showing in the background. So let me open up, for example, in the X-ray we have background HIPs from XMM Newton. In the optical we've got the DSS2, we've got many others. I'll also open up the near infrared, the mid-infrared from All Wise. Let's open up another one that's from Spitzer, and let's open the far infrared from Herschel Pax. And you see that we have this slider here along the bottom, so you can start actually play through all of these skies. Let's pause this, and you can also take a hold of the slider and pan through yourselves. So if I go back to optical. Now I want to show you how to find and download data. So these buttons over here with the numbers are showing us how many imaging observations are available in this region of the sky, this rectangular region. It also shows us how many catalogue sources are available and how many spectra are available. So these three buttons, we can access data, and also this fourth button here, which I'll show you in a moment. So let's first click on images.
Here we see a tree map with the missions that have available data in the field of view of the screen. You can filter the missions by wavelength using this slider at the bottom. For example, if you're only interested in high energy, you could move this button along here, or perhaps you just want to see infrared to radio, then you can slide along here. If you want to find out any more information, then we've got these little help buttons with a question mark all over. So you can click on this, it gives you information, and it sends you to a link for the full documentation. And clicking on any mission will bring up the data. So let's click on Hubble in the optical, and we immediately see the footprints appearing in the sky and also the metadata down here in the data panel. And you can interact with the sky, so you can click on the footprint and the corresponding row highlights, or vice versa. You click in the table and the corresponding footprint will highlight. You can also filter any column. So let's take, for example, the instrument, and I could just look for ACS, and then immediately we see the results shown here. We have postcard previews that load up the postcard directly from the European Hubble Archive. And if you click on the archive column, you open up the archive directly on this observation. This little icon centers you in the observation, so you can find where you are. So to download the data, either select one, a few, or all of the data, and then go to this download button here and click on Data Products, and you download the data straight away. So this is the same for all other missions. So if we load up XMM, it's exactly the same. We can see the postcard straight from the archive. We have direct links to the archive, so it will load up this observation. And you can download your observations as well. So it's very easy to download by selecting the data you want and clicking on the download button. And it's the same for all the other missions. So let me close all of these, and I'm going to show you now the catalogues. So here we have the button for the catalogues, and you find a very similar tree map for all catalogues available. This can also be filtered by wavelength. Over here we have an interesting cluster by the look of things. So let's load up the Gaia catalogue. Here we are showing the coverage of the catalogue because there are so many sources in this field of view, but we can filter. So if I right click on one of the stars, we can actually search in Sinbad, for example, to see what this star is. It looks like it's this young stellar object, HD 37525, and we have the parallax and the proper motion values here. So let's go back to ESASky and let's start filtering on the coverage. So I'll filter the parallax from 1 to 3. The proper motion between 0 and 2 in RA, and the proper motion in DEC between -2 and 0. And since this is an astrometric catalogue, we are seeing the proper motions here. The proper motions are indicated by the dotted lines. If you zoom in a lot on a source, then you'll see that the dotted line will turn into a solid line, and that's the true proper motion. And if you want to download what you've been filtering, and of course if you want to download any of the tables, just select all and click on the download button, and you can either choose a CSV or a VO table. So we can find out more about this star as well by selecting the publications icon. So this is this button here. When I press this, all sources with an associated publication are shown. So I can then go to this star and we see that there are 67 publications. If we click on it, then we'll load up all of these publications. Now this is accessing the service provided by CDS, who have linked all publications to sources. You can again filter any column, so we could search, for example, for cluster, and here we can find out a bit more about this cluster. We can, if you click here, then you'll open up the paper directly in ADS, and this little parchment button allows you to open up all of the sources in the publication, and you can start clicking through them, and they're all highlighted in by a green square. So let's go back to the region that we were in, and you can now see all of these sources. If you want to distinguish between the sources that you've loaded and the Gaia catalogue, we can, for example, change the colour of the footprints or of the sources. So here we go. Here we can see the Gaia sources now as well. And linking all of these services enables faster data discovery, which we hope your science can benefit from. Let me close everything again, and let me close the publications. And the third button to find data is for Spectra, and it's very similar, almost identical to downloading and finding and downloading imaging. So let's, for example, we have access to LAMOST from the Chinese Academy of Sciences, and you can see a preview of the spectra, and this is coming straight from the archive in Beijing, and if you click on here we go straight to the archive as well. So we can load up all available spectra within the region, and you can download it exactly as we've been downloading with the images and the catalogues. So you click on this button here. So we also have a fourth button to access data. It's this one here, and this allows you to explore data from other external data centres. The data hasn't been curated by us, but we're accessing these data centres. We're using the Table Access Protocol, which is one of the virtual observatory standards that many astronomical data centres are using as one of the means to expose their data to the public. And currently, this is accessing data from ESO, CADC in Canada, and MAST in the US. So if I click on ESO, you can see here all the different data types that you can search for, and this includes ground-based and space-based data, obviously. So we have spectra, images, visibility, and measurements. So there are also cube data and time series available. So if I go to images, we can load up the ESO VLT images in this region. This is still interactive, so we can select footprints on the sky and interact with the data panel. And if you want to download the data, you click on this access URL and you select the first one, which is the Science Ready Fits. Click on this and you begin to download the data directly from ESO. And you can do exactly the same for the other data centres. Now let's show you a couple more features. So via this button here, you can upload your own list of targets. So let's upload a target list here. You see that it's just simply a list that can be resolved by Simbad or coordinates. And you can also add a description. So if I open this, then if you've added the description in the file, it pops up here. And we also have a lot of other target lists, example target lists for you to take a look at. This button here opens up the observations planning tool for James Webb. So if you click on the plus button and you're given 5 instruments of James Webb, so select one and then you can select any of the apertures, and you can also click on all of instruments to see the full focal plane. You can change the RA and DEC, and you can rotate and you can do this manually here. And once you're happy with all of this, you can copy the coordinates and data, and then this can be used in the James Webb Astronomer's Proposal tool. And this tool is for a quick look on how you'd like to do your proposals before moving on to the APT. So finally in ESASky, I want to show you the Solar System Objects feature. In the search box, you can search for over 800,000 solar system objects, currently for 3 missions, Hubble, Herschel and XMM, Newton. And the ESASky team have created a pipeline that calculates the orbit of the SSO as seen by the satellite and cross-matches this against the images in the 3 archives. So we have targeted and we also have serendipitous results. Let me show you an example. If I type in Psyche, we are given the option to search for the asteroid, and we're told that we have some Herschel observations. So when I click on this, we're zoomed out on the whole sky, and what we see here is the orbit of Psyche as seen by Herschel during its entire lifetime. And if we centre on the observations, we can see them here, the footprints in the sky. We see that we've got 2 Pax and 2 Spire observations. Let me change the background hips now to Pax. And if we zoom in here, so we can see falling perfectly on the orbit, the asteroid appearing twice because the hips were made up from the 2 images. We also see this in the postcards as well, coming from Herschel. And these were not targeted observations, so the target for these observations were L1551, which is a dark cloud nebula. So these are serendipitous observations. Now, a NASA mission is going to Psyche in the 2020s, so these serendipitous observations by Herschel could help to refine some of the physical properties of the asteroid. And there will be a publication out soon by the team describing the SSO algorithm and the analysis of these Herschel images on this asteroid. So finally, let me take just a few minutes to show you the pyESASky Jupyter widget and some typical things that you can do in a Jupyter Notebook. So I have the notebook on the right and pyESASky on the left. You can go to any target. Let me just start running this notebook. You can set the field of view, you can change the background skies, you can upload any of the data that's available in ESASky and you can load it up into your notebook. So here we have an example for 2 source catalogues and for Chandra. Many users ask for cross-matching functionality, so this is how you can do it in a notebook just using an AstroPy library and then send the cross-match table very easily back to ESASky. And similarly, people ask if we can connect to Vizier, so this is how you can load up a Vizier catalogue into ESASky using AstroQuery. And you can also load up your own tables from files, create your own tables, send them to ESASky. There are many more things that can be done, so see our example notebooks here. The creation of ESASky isn't possible without collaboration, in particular with other data centres. For example, we are using the Aladdin Light tool to visualise the sky developed by CDS, the data centre in Strasbourg, and we are using their astronomical name resolver Simbad and Sesame. We have worked with the AstroPy community, in particular AstroQuery, to create an AstroQuery module. And of course, we've created pyESASky to allow users to do more sophisticated studies of the data. And let me emphasise that all of the interoperability you see in ESASky is thanks to the International Virtual Observatory Alliance protocols and the international collaboration that we have between astronomical data centres. These are all the people and institutes that we have collaborated with so far, and we welcome contributions from anyone who's interested, so please contact us. Here are a number of useful links for further reference. And in summary, ESASky is a suite of tools developed for scientists to facilitate data discovery and archival science. Our vision is to link to all major astronomical data centres and to help enable science that couldn't happen before when you didn't have access to so much data in the one place. And finally, if you have any feedback, do contact us via User Echo, and please acknowledge us if you use ESASky or pyESASky for your science.
Many thanks.